Scientists are super curious about Proxima Centauri B, a planet circling the closest star to us. It's just over 4 light-years away and might be a place where life could exist outside our solar system, so it's a top spot to check out. For ages, finding planets that can support life has been a huge deal, and planets like Proxima B get everyone excited about exploring space again. What's really cool is that some planets could even be better for life than Earth. They might have nicer weather, tons of water, and big chunks of land. Big thinkers like Michio Kaku think we should look for planets that are even better than Earth, not just Earth-like ones. He thinks that for humanity to stick around long-term, we need to spread out to other planets. Earth is awesome, but stuff like asteroids, volcanoes, or even the sun changing could mess things up. Some scientists are saying that we shouldn't just focus on planets that are like Earth. We might be missing out on places that are even more suited for life. Back in 2014, Renee Heller and John Armstrong pointed out that it's not just about being in the Goldilocks zone, where water can exist. Things like the air, magnetic field, and the star itself matter too. Water is still a big deal, but it's not the only thing. For example, Europa, a moon of Jupiter, is way outside the habitable zone, but it has a massive ocean under its icy surface. This shows that life could pop up in unexpected spots, so we need to rethink what we look for. Heller and Armstrong say we should look at all sorts of things about a planet, like its size, age, how it moves, and if it has geological activity. The type of star is important too. While we usually look at planets around stars like our Sun, some people are checking out planets around orange stars. These stars live way longer, which could give life more time to get going. Complex life took about 3.5 billion years to appear on Earth, so a planet around a long-lasting star might have a head start. But too old isn't good either. A really old planet might cool down and lose the stuff that protects life from radiation. Heller and Armstrong think the sweet spot is a planet that's 5 to 8 billion years older than Earth but still active. Size and weight also matter. A slightly bigger planet, 10% bigger than Earth, could have more space and thicker air. A heavier planet, 50% heavier, could stay warm longer. These things would be great for life, even if the gravity is a bit stronger. Warmer planets might have more life. The Amazon rainforest is packed with life because it's warm and wet. So, slightly warmer planets might be even better. Also, planets with lots of islands and coastlines could be ideal for sea life. Even though it's tough to find these perfect planets, scientists are hopeful. The Alpha Centauri system is a good place to start. Proxima Centauri B is there, but it might have some issues because of its star. Red dwarf stars can be kind of violent, which could strip away a planet's atmosphere. We've found over 5,000 planets so far, and at least 24 of them might be better than Earth. KOI 5715.01 is one to watch and is about 700 light-years away. As we get better at finding and studying planets, we might realize that Earth isn't the best place out there. With some new space missions, we'll be able to check out planets in more detail and maybe even find signs of life. This means we're changing how we think about which planets can support life. Things like how a planet is tilted, its atmosphere, and even the clouds play a big role. A thick atmosphere could keep a planet warm even if it's far from its star. On the flip side, a super shiny planet could stay cool even if it's close to its star. Scientists also like looking at systems with multiple planets where life could spread between them. All of these ideas are changing how we search for life. As we explore the universe, we're realizing that there's a lot more to habitability than we thought. We're checking out all sorts of planets and atmospheres to see what's out there. One of the coolest things is how much a planet's atmosphere can affect whether it can support life. The atmosphere keeps the planet warm and protects it from bad stuff. Also, certain gases like oxygen or methane could be signs of life. Even clouds can help keep a planet's climate stable and protect it from radiation. How a planet is tilted and the shape of its orbit also matter. The right tilt can spread heat around, while a circular orbit means steady weather. Systems with multiple planets can also be helpful because they can create geological activity that makes a planet more livable. The idea that life can spread between planets is also getting some traction. If life exists on one planet, it could spread to others through space rocks. Telescopes like the James Webb Space Telescope are key to finding life. They can analyze light from planets to find gases that might mean life is present. They can also measure temperatures and even see weather patterns. The more planets we find, the more we realize how diverse they are. Each new planet makes us rethink what's possible. Some planets might be totally empty, but others could be just right for life. On Earth, it took about 3.5 billion years for complex life to show up. So, a planet around a really stable, long-lasting star might be way more advanced. But there are downsides to being old too. A planet that's too old might cool down, lose its volcanoes and magnetic field, and then get blasted by space radiation. Heller and Armstrong think the sweet spot for a superhabitable planet is about 5 to 8 billion years older than Earth, but still young enough to have those important geological features. Size and mass matter too. A planet a bit bigger than Earth, like 10%, would have more space and maybe thicker air. A planet with 50% more mass might hold onto its heat longer, keeping those volcanoes and magnetic field going. Those are good things for life, even if the stronger gravity might be a pain for humans. From a life point of view, warmer planets might have more going on. On Earth, rainforests are the most alive places, warm, wet, and packed with life. A bit warmer overall, with enough water, could mean even more life. But too hot or dry would be bad, like deserts. The planet's layout matters too. If a planet has about the same amount of land and water as Earth, but the land is broken up into islands and small continents, that could mean more shallow coastal areas. Those areas are great for sea life because they get sunlight and nutrients, so they could be important elsewhere too. It's hard to find and study these ideal planets, but scientists are hopeful. The Alpha Centauri system is a big target because it's close. Proxima Centauri, the closest star, has a few planets, including Proxima Centauri B, which gets a lot of attention. It's in the habitable zone, but it has some problems. It's probably tidally locked, meaning one side always faces the star. Also, stars like Proxima Centauri can have violent flares and radiation that could strip away a planet's air. So, it's not a sure thing for life, but it's close enough that we're still interested. Right now, we've confirmed over 5,000 planets, and thousands more are waiting to be checked out. Out of those, at least 24 might be even more livable than Earth. One standout is KOI 5715.01, about 700 light-years away. The search for superhabitable planets is making us rethink what it means for a world to be friendly to life. As tech gets better, we might find that Earth isn't the best after all. Planets with more water, longer-lasting air, and stable volcanoes might be even better. Future missions with powerful tools like the James Webb Space Telescope will let us dig deeper into these planets, maybe even finding organic stuff or signs of life. This new way of thinking is changing how we study space biology. Researchers are now looking at things like how a planet tilts, its orbit, how thick its air is, and how many clouds it has. For example, thicker air with more greenhouse gases could keep a planet warm even if it's farther from its star than Earth. Or, a really reflective planet could stay cool even if it's closer. Scientists also look at systems with multiple planets in the habitable zone where stuff can be exchanged through meteorites, which could help spread life. This idea, called panspermia, says that life might not have to start on each planet, but could be seeded from somewhere else, especially if the planets are close. These ideas are changing how we look for life, suggesting we might find entire systems where life has had a chance to go wild. As we explore more, we're realizing that habitability is way more complicated than we thought. The search for life-friendly planets isn't just about finding Earth twins anymore. The definition of a livable world has gotten bigger, and scientists are now checking out all sorts of planets, orbits, and atmospheres that might support life in ways we don't even see on Earth. One cool thing is understanding how a planet's air can affect its habitability. The air not only controls the temperature, but also protects against radiation. A planet with thick, stable air full of greenhouse gases could stay warm even far from its star, while a planet closer to its star might stay cool because of reflective clouds or ice. Also, certain gases like oxygen, methane, and ozone can be signs of life, especially if they're out of whack, meaning something biological is probably making them. Another interesting thing is planets with lots of clouds. Clouds can help keep a planet's climate steady by bouncing sunlight and balancing heat. They can also protect against solar flares and radiation, which is good for planets around stars that are kinda wild, like red dwarfs. How clouds move and act is important for whether a planet is in the habitable zone and can support life long enough for cool stuff to evolve. Also, the way a planet tilts, its axial tilt, plays a big part in its climate and seasons. A planet with a good tilt can spread sunlight more evenly, so there aren't crazy temperature swings, and there are more stable and livable areas. But a planet with no tilt or a huge tilt might have rough and weird climates, which wouldn't be great for life. How round or oval-shaped a planet's orbit is, orbital eccentricity, can also affect climate. Really oval orbits mean the planet gets way closer and way farther from its star, causing big temperature changes. But a circle-like orbit means things stay pretty steady, which is good for life developing. Scientists are also getting into systems with multiple potentially habitable planets. In those systems, the push and pull between planets and moons can cause geological activity and heat, which can help with habitability. Moons like Europa and Enceladus in our solar system are good examples. They're warmed by the gravity of their planets, not sunlight, and they have oceans under the ice that might have life. If similar stuff is happening in other systems, it means there are way more places where life could be. The idea that life can be transferred between planets through asteroid or comet impacts, panspermia, also makes sense in these multi-planet systems. If there's life on one planet, impacts could send rocks into space, which could then seed life on another planet. In systems where planets are packed close together, that stuff could be pretty common, giving life more chances to spread. Finding signs of life and figuring out if a place is habitable depends on new telescopes like the James Webb Space Telescope. By looking at the light from distant stars and the air of their planets, we can find tiny bits of gases that might point to life. Fancy tools can break down the light and show us the unique signatures of different elements and compounds. The JWST is really good at this because it can see in infrared, which lets it peek deep into planetary atmospheres, find complex organic molecules, and even measure temperatures and weather on distant worlds. As we find more and more planets, we're learning how diverse they can be. Over 5,000 planets have already been confirmed, and that number keeps going up. Each new discovery adds to the puzzle and makes us rethink what's possible when it comes to planets and how tough life can be. Out of all those worlds, some might be totally dead, burned up, or frozen over. But who knows what else is out there?